So hello everyone, welcome to another video. Today we are going to solve the problem ODDMATRIX, which is the fifth problem of the last contest, Starters 107 Day 2. Now I will count to 5. Okay, let's first let the problem load. Yeah, I will count to 5. You can try reading the problem. Meanwhile, you can pause the video and try reading the problem. So 1, 2, 3, 4 and 5. So yeah, I hope you would have read the problem by now, and now we'll start with the explanation of the problem. So okay, yeah, so what does the problem is saying? See, suppose you have a grid like this. It can be of even size or it can be odd size. The size n is given to you. Now what you need to do is you need to fill the elements in the grid from 1 to n square. How many elements will be there? Total n square, right? So you need to fill the grid with the elements of from 1 to n square such that obviously you have to fill all the elements from 1 to n square, so you cannot repeat an element. That is the first thing. Second thing is sum of every row should be odd. This is one row, right? So every row, every search row, when you will sum it, it should give you an odd answer. Similarly, every column should also give you an odd answer. Similarly, if the size is even instead of odd, same thing, you have to fill the elements from 1 to n square. All rows should give you odd answer and all the columns should give you odd answer as well. So this is the problem, and now you need to think what can we do. So again, you can pause the video and think for an approach. I will count to 5 meanwhile. So yeah, 1, 2, 3, 4 and 5. Okay, so first of all, let me make it very clear. This is one of the problem of the constructive type. Now if you don't know about the constructive problems, basically in a constructive problem you have to construct something. Here you have to construct a grid satisfying few conditions, and this is a very obvious problem of the constructive problem. And what happens in a constructive problem is you do not have a specific way to solve it. Since it is a constructive, you can construct multiple answers in most of the cases. Here as well, it is in this question as well, it is possible to construct multiple answers. So we will try to figure out one of those ways, and you can try figuring out other ways as well. If you want to move it my way, that will be fine. I will show you the code as well in the end, but there could be multiple ways. That's what I am trying to tell you. And one more thing, you might feel, hey, how did you came to this answer? So well, that is something based on observation, or because there's, as I said, constructive problems, so like you have to construct something, so you need to figure out many cases, many edge cases, and then at the end you come to a conclusion what can you do with the problem. So what I am just trying to convey from the problem is, see here, you need to make the sum odd, right? So to make the sum odd, what you need to do is, you suppose you want to make the sum odd of every row. You want to make sum of odd every row, right? Sum of every row as odd. So what can you do? In every row you should have either one odd element or three odd element or 5 odd element. Like the size of this matrix is 5 by 5, so you can have 1, 3 or 5. If it would have been 7 by 7, then you should also have a 7. You can also have a 7, right? Let's just figure out two things. First of all, when you are going to fill the number from 1 to n square, that is 1 to 25 in this particular case, how many odd numbers are there? How many odd numbers are there? So it's pretty simple. It's 13, right? There are 13 odd elements and 12 even elements. So we are supposed to fill 13 odd elements in 5 rows. So how can you do that? So see, again, it is one of my ways. It could be different. What I am saying is, fill the first 5 rows. So fill the first row with all 5 odd elements, next row with 3 odd elements, next row with again 3 odd elements, next row with 1 odd element, and next row with again 1 odd element. So now this will lead 5 plus 3 plus 3, it's 11 plus 12 plus 13. So you can see we have used all 13 elements. And now fill all the remaining one with the even. Now fill all the remaining one with even. Fill all the remaining one with even. So now let's look at this case. What will be the sum of first row? It will be odd. What will be the sum of second row? Odd. Third row? Odd. Fourth row? Odd. Fifth row? Odd. So sum of all rows are odd. Correct. Now let's try to look at column. Obviously we are not repeating the elements, as we know we are just moving from 1 to 25 to fill all the elements. Let's try to look at the columns now. So you can see this column has 5 odd elements, so the sum is odd. This column has 3 odd elements, so again the sum is odd. This column is also having 3 odd elements, so again the sum is odd. This column is having 1 odd element, so again the sum is odd. This column is also having 1 odd element, so again the sum is odd. So you can say this algorithm or this technique or this way of filling the grid will work. What we will do, fill 5 odd number in the first row, then 3 in the next row, 3 in the next row, 1 in the next row, and 1 in the next row, and so on. So yeah, I guess it was pretty simple one. That was for the odd one. Now if we will really go on filling the elements, so it would look like something like this. It would be 1, or should I have a new page? I guess it will be something like this: 1, 3, 5, 7, 9. First row filled, then second row 11, 13, 15, next row 17, 19, and 21. Then next row it will be 23 and 25. Then we need to fill the even element, so it will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So this is a matrix which is a valid answer. You can cross verify it by adding the sum of rows and columns, but that is not required. So this we have got the answer for odd case. Now we will try to figure out an answer for even case. So let's try to look at the even case. Again, see here, in even case, when there are 4 rows and 4 columns, what you can conclude is, again, you need to have 3 odd elements in each row or 1 odd element in each row, right? Total there are 1 to 16 elements, and out of which how many odd elements are there? There are 8 odd elements. So it is very clear that 3 into 2 plus 1 into 2, that is, you need to fill 3 rows, 3 odd in one row, 3 odd in second row, 1 odd in third row, and 1 odd in fourth row. So all the 8 elements will be covered: 3, 3, 1, and 1. Okay, now if you will look at carefully here, one thing you will notice that, hey, how many okay, what is the sum of this row? It's odd because there are 3 odd elements. What is the sum of this row? Odd because there are 3 odd elements. What is the sum of this row? It's odd because there are 3 odd elements. What is the sum of this row? Well, it's not odd, it's also odd, okay, because there are only 1 element. That's fine. But now what is the sum of this column? There are 4 odd elements, so the sum is even, because when you will combine 4 odd elements, 3, 1, 5, 7, you will always find out that the sum of 2 or 4, the sum of even number of odd elements, is also always even. So this column will give you an even answer, which is not valid. So we can say this case is not valid. The same we were doing in the odd case, it is not valid in the even case. So now what can we do in the even case? That might be a question, that what shall we do in the even case? Okay, so to answer that, see, what can we do in the even case? That is the question. So let's try to figure out a way what can actually we do in the even case. Suppose we move this one. Okay, suppose we move this. Okay, let's just, okay, suppose we move this last one here. So now you can see here are odd elements, but here is even, so it is again invalid. Now what can we do? Okay, now suppose what I am trying to say is, let's just take out the eraser and just listen me carefully, okay, because again it is a constructive problem, so we will have to figure out a way how can we set up the numbers in the matrix, and this will require some what you can say observation. see, first 3 are filled here, right? Now what we need is, we need somehow, let's change the color of the pen. Suppose now I will fill these 3 rows. Just hear me out. These 3 columns of this particular row. Then one we will fill here. Then one we will fill here. Just hear me out. What I am trying to say is, we started from the first row. We started with the first column of it, and we filled n-1 columns, like till the end. Then if we would have filled this row as well with the same starting point, then the problem would be, it would have given us an even sum. So what we did, we started filling from here. We started filling from the next point. What it allowed us to do is, we filled this point as well. This column was having zero odd elements still here, right? So by filling this, we make sure that there is one odd element here as well, right? Because earlier it's n-1. So the next time, when we will try to fill another row with some odd elements, it is not going to cover till the end. It is the only possible case where we can cover till the end. If you are not able to get what I am trying to say, let's bring another board and try to figure out there. We will draw 6x6 board just to have a better understanding. So let's try to 1, 2, 3, 4, 5, and I guess it's 6. Yeah. Again it's 1, 2, 3, 4, 5, and 6. See, in the first case we are filling this 5 row, right? If we again fill this 5 row, what will happen? This column will never get touched. Next time when you will try to fill 3 rows, you are not going to touch this column. Again, when you will fill 1 row, you are not going to touch this column. So what I am proceeding with is, I will fill 1 column later. Now we want to fill 3 columns. We will start filling from here. Then the next row will be from 1 step later. Then we need to fill 1 column. We will start filling from here, and in the next row we will fill from this column. Now this is just an, you can say, observation. This is a method of filling the array. Now let's just try to figure out whether this method works or not. Have you got it? What I am trying to say is, in first row we tried to fill 5 elements. So we started from the first column itself. In the second row we started from the second column. Now again now it's the 5, filling 5 elements are done. Now we are start to filling 3 elements. So to fill 3 elements, we will start with column number 2. We filled 3 elements. Then in the next row we moved 1 step ahead and we started filling from the next step. Then the number 3 elements number 3 are also done. Now for element numbers 1, we started with the third row, and in the next step third column, and in the next step we started with 1 column ahead. What it allowed us to achieve is, there is just 1 element in this row, so it is in this column, so it is going to give an odd sum. There are 3 elements in this column, so again it is going to give an odd sum. There are 5 elements in this column, so again it is going to give an odd sum. Again you will check here, there are 5 elements in this row, so it will also give us an odd sum. There are 3 elements again in this one, so it will give us an odd sum. There is 1 element in this one, and it will again give you an odd sum. So yeah, this was about the problem. Now I hope you would have understood what we have done here. If not, then try to dry run it, because doing the dry run would help you to understand what we just did. If you are still having any doubts, you can ask in the comments, we can discuss over there. But as of now, I guess it is pretty clear that what we are trying to do and what we have done. What we have done, basically, we will start with the first row, we will fill n-1 elements. Then in the next row we will start with the next column, and we will fill again n-1 columns of that particular row, starting from the second. And then next time we will reduce it by 2 number of elements we are going to fill, and we will start with the next index. So here we were starting with the 0th index, here we will start with the first index. Then the next row of it will be filled with starting from the next index of this particular row. and so on. It will be done like this. So yeah, I hope it would be clear. We have tried the constructive method. See, constructive method, as I said previously, constructive algorithms are those algorithms which can have multiple answers. This was just one of the answers which I figured out. You might have a different answer, and that's completely fine. You can put your answer in the comment box as well. I hope you would have understood the problem. If not, then please comment. If you have not understood, we will try to discuss over the comments as well. Someone has said that I should try to make the video in English language, so I've tried making the video in English. If you think it's not you are not comfortable with it and I should switch back to Hindi, you can put in the comments like I should create a poll or something. So think of the comment box as a poll. If you want me to make the videos in Hindi, then put down Hindi in the comments, and if you want to make the videos, if you want me to make the videos in English, then you can put the English in the comments. I will continue with that particular language only. As of now, we will start with the code. We will try to write the code in CPP. I hope you would have get the concept what we are trying to do in this problem. So we will start with code. So let's just start with the code. So first of all, what I will do is I will simply take the number n, and then we will first write the code for odd, because odd one was quite easy, I guess. So for odd, what we did is, okay, first of all, what we will do, we will make a vector of ll as answer of size n by n, and we will initialize with it with -1, because just to make sure we should be knowing that where we have filled the odd elements and which position are yet to be filled. Now what we will do is we will first fill the first row with all zeros. So answer of 0 comma I will be not with zeros, it will be with the odd elements, and we will proceed the odd elements by 2. So odd elements are going to start from 1, and then in each step we are going to increase it by 2. Now what we need to do is we need to now fill the remaining number of rows, and for each row LLJ equal to, I guess it will be +2. And what we will do, in the first case we filled all the rows, right? Now in the second case, what we need to do is we need to fill n minus twice of I guess. Do we need to n minus twice of I? Here, when we are here, I is 1 and I is 1, we need to fill the 3 elements. So 5 minus 2 times 1 is 3. It's so yeah, right. I guess this will do the trick. What we will do is we will fill answer of ij with odd, and then we will increase the odd by 2. So yeah, we will do this thing, and I guess we are ready. Okay, again we need to fill the next column with the same. So yeah, we will simply copy it and paste it to fill the next row as well. So you can see here we need to fill this row as well with 3 elements. So we are doing the same. We filled the first row, and then we are filling the next row of it, and then we will move to this particular row, and then we will try to fill this 2 row. So yeah, I guess that's it for the odd one. Now we will try to write the code for even. Okay, we have filled the even elements, but we have not filled the odd elements yet. We will fill the even elements later. We have filled the odd elements as of now. We will first try to write the code for filling the odd elements in the even array. N by n. If n is even, then we will try to fill those. So to fill the even size one, what we will do, we need to start from 0 again. So let's start with 0. Let's go to less than n, move 2 rows. Okay, so in first row I need to fill 3 elements. So how can I make sure that I am filling 3 elements? So I can say I have to go from 0 to n minus 1 minus I, and it's not from 0, it's actually from, you can say it's 0 by 2, it's 2 by 2, so it's from I by 2 to n minus I minus n minus 1 minus I. In first one it will feel okay, it's n minus I minus 1 minus I minus 2, and see, it's a basic pattern filling. So if you are confused with how I am filling this thing, so just try to make the pattern. This is something we have learned in first year, how to make patterns. So this is the same, and then in the next step I need to start I by 2 plus 1, and then I need to go till n minus I minus n minus 1 minus I by 2, and then j plus plus, and then we will try to fill it is the next row, so j as odd, and then odd plus equal to 2. So yeah, it is a basic pattern printing, so I don't think there's much to explain in the code. We have just tried to make, even the code could be completely wrong. It might be the case that I'm completely wrong with the code, but that's fine. We will try to figure out if the code goes wrong. We will try to figure out what exactly is incorrect in the code. Now what we will do, we will try to fill the remaining elements with even numbers. So if it is -1, that is it's not filled yet, so what we will do, we will fit it with even elements, and then we will increase the even elements by 2. That is basically we will move to our next even element. So even elements start by 2, and after this I guess our answer would be ready for both odd case and even case. So yeah, basically we filled our even numbers letter, because we know that it is going to be the same for both odd and even. We don't need to write a separate logic for that, so that's why we did that. And now we will try to print our matrix, which will be just okay, which will be here traversing to I only. And now let's try printing this. As I said, it might be completely wrong. That's completely fine, because okay, so it's 1 3 and 5 7 2 4 6 9. It looks fine to me as of now. We will try to submit it. I am not sure whether it will be accepted or not. There is a very high probability that it might get wrong somewhere, but okay, let's try to print this. Partially correct. Okay, I guess it is correct for odd one and it's not correct for even one, something like that. So yeah, I guess it's no, okay, sadly I guess it's correct for even one and it's not correct for odd one. Okay, it's correct for even one, but it's not correct for odd one. That is it. It is correct for even one. It is 51 points, so it is correct for even one, but it's not correct for odd ones. So we will see what we have made mistake in our even, so that it's going it is going incorrect. Okay, let's just try to see what is being done here. When we are at a 5 by 5 matrix, see, we are also trying to figure out what we have done wrong. Suppose let's open a new board. Suppose it's 9 by 9, so we have filled 9 elements in the first column, which is first row, which is completely fine. Then for the second row, okay, so yeah, then for the second row we have said we need to go up to 9 minus 2, which is up to 6. So in the first row we have gone up to 8, 0-based indexing, that's fine. In the second row we have gone up to 6. In the third row we have gone up to 6, and then it will be I minus I. Okay, now here I is actually okay, here I is actually my bad, n minus 2 was 6 here, up to 6 here, and then next step it was 9 minus 4, which was 5. So we were going up to 4 here, which is correct, I guess, which is correct, I guess so. And then in the next step we were going up to 2, and then in the next step we were going up to 0. So our array was looking like something like this: 8 6 6 4 4 2 2 0 0. So odd elements, odd elements, odd elements, odd elements, odd elements. 9 here, 7 here, 7 here, 5 here, 5 here, 3 here, 3 here, 1 here, 1 here. I guess everything looks fine to me. I don't know where we are going wrong with this. I guess everything looks fine to me. Okay. So we filled the first row with all the odd elements. That's fine, I guess. We started with the second row, and mm-hmm. Oh, okay. I guess it's completely fine. Mm-hmm. It is completely fine. Wait, how many elements we are going through here? It's 1, 3, 5, 7, 9, 11, 13, 15, and 17. Then we are going 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, 49, 51, 53, 55, 57, 59, 61, 63, 65, 67, 69, 71, 73, 75, 77, 79, and 81. Yeah, it's fine as well. Okay. To me, everything looks fine. Sorry. I'm just not able to get if there is something wrong with the code. We have started with 1, we have gone till n, and at every step we are going n minus 2 times I, which is like in the first case it should be up to n, in the second case it should be n minus 2, which is spare 2 characters, in the next step spare 4 characters, in this next step spare 6 characters. Mm-hmm. Everything looks fine to me, at least. Okay, okay, yeah, I got it. In the next step it's actually 3 and it's not 2, because we are increasing I by 2. So what we can do is we can make a counter or something, count, which will be initialized to 1, and we are actually going to reduce it by count instead of 2 minus I, because I is increasing by 2 while we need to increase it by 1 only, and then in the next step we can increase the value of count. So just to clear the confusion, what happened is, see, we need to make it like this: 8664222. So in the first step it was 8, which was fine, it's less than 9, so it's 8. In the next step it was n minus 2 times I was 1, so n minus 9 minus 2 times 1, which is or 7, up to 7, which you can say up to 6, because zero based indexing, that's fine. In the next step I was not 2, in the next step here I was 1, but in the next step I was not 2, it was 3. So it was reducing it by 9 minus 2 times 3, which was up to 5. Okay, 9 minus 2 by 3, it's like, okay, that is a mistake I did there. 9 minus 2 into 3 is actually 9 minus 6 is actually 3, and when you will go to the zero based indexing it will be up to 2 only. So you are skipping these steps, and that is just because I is increasing by 2, but we need to have a factor which will increase by 1 in order to reduce that. Okay, so we can make it I as well, like we can make some factor of I here, some I by 2 or I plus 1 by 2, something like that. But just to keep this thing simple, we are introducing a count variable. Now let's try submitting this. I really don't know whether this will be accepted or not again, but yeah, let's try this. So see, that is the beauty of the constructive problems. You just figure out a solution and then you write the code for it. You might get some error into it, and then you figure out what is the exact error, and then you try to code for it. And yeah, so it is accepted. So yes, this was about the problem. Again, see, This was about the fifth problem of this particular contest. If you have enjoyed the content, please write down in the comments, subscribe to the channel if you haven't, and tell me about what do you want next in the channel. Should we proceed with the English language or Hindi language, or what else things should we do on our channel apart from the problem solving? All your comments will be entertained in the comment box, so please put your comments in the comment box, and I will see you in the next one.